section 15.5, we're going to be solving radical equations. All right. So to solve the radical equation, we isolate the more complex radical. And then you square both sides and repeat. We also always check for extraneous solutions. An extraneous solution is when you get a negative inside of a square root, or when you have it's either a negative inside of a square root, or when you have a square root equal to a negative number. Let's get into this. So let's solve the following. Let's say we have the square root of x plus 20 is equal to 4. We have to do the hardest radicals by itself. You always want to isolate the radical, and then you square both sides. And we get x plus 20 is equal to 16, or x would be negative 4. What if we had 2 square root of x plus 7 is equal to 6? Again, we want to isolate the radical, so let's subtract 7. Divide by 2. We get the x completely by itself, and now we have to square both sides to get rid of the square root. Negative 1/2 squared is negative 1/2 times itself, or 1/4. The problem is we should check our answers. If you were to plug in negative 4 here, negative 4 plus 20 is the square root of 16, which is 4. So this works. If you plug in 1/4, you get 2 times the square root of 1/4 plus 7. 2 times 1/2 is 1 plus 7, which is 6. So this actually doesn't work. This would just be no solution. We can tell it's no solution at this step, when you get a square root is equal to a negative number. But you could always check your answer, and either way, the answer for this is that there's no solution. What if we had the square root of 3x minus 8 is equal to the square root of x plus 2? Well, let's square both sides. 3x minus 8 is equal to x plus 2. Bring the x over, add the 8, and then we just get x is 5. Check your answer. 15 minus 8 is the square root of 7, which is equal to the square root of 7. So checking our answer, that works. How about the square root of 25x squared plus 3x minus 27 is equal to 5x? What we could do is just square both sides. And this just gives us 25x squared plus 3x minus 27 is equal to 25x squared. Bring the 25x squared over. We get 3x minus 27 is equal to 0. Bring the 27 over and divide by 3, x would be 9. We check our answer and get the same thing. Yeah. Yeah. The way we get rid of a radical is by squaring it. Let's keep going here. What if we had the square root of x is equal to x minus 20? Square both sides. And if we FOIL this out, we get x squared minus 40x plus 400. Bring the x over, make it equal to 0. We just have to figure out how to factor and solve this. So numbers that go into 400 and add up to 41. Let's see. What would work here? Yeah, sometimes it's tough when the numbers get bigger. Let me just see here. All right, so what multiplies to be 400? Obviously, 1 and 400 wouldn't work. 2 and 200 doesn't work. 3 doesn't go into 400. So maybe 4 and 100. Obviously, that's no good. They have to add up to be negative 41. We talked about factoring trinomials. Let's see, 400 divided by 5. That's 80. We're getting closer to 41. 400 divided by 6 doesn't work. Divided by 8. 8 and 50. No. 400 divided by 9. Nope. And then 40. No. What else? 400 divided by 12. No. No, it is possible. It's just, I wish the numbers weren't so big. 16 and 25. And those add together to be 41. Sometimes it takes a little while to get there, but when we talk about factoring trinomials, this would be negative 16x minus 25x plus 400 is equal to 0, cutting it down the middle. Take out an x and x minus 16. Take out a 25, it's x minus 16. So x minus 16 times x minus 25 just gives us 16 and 25. By the way, what we do at this step is we set the factors equal to 0 and solve. We get x is 16 and x is 25. If you were to plug these in, this would be 16 minus 20 is a negative number. So a square root can't be negative, so this wouldn't work. If you plugged in 25, that would work. So with radicals, you just want to make sure you have your answer. How about this one? If we had square root of 2x plus 6 minus x is equal to 3. We have the x on the other side. Then square both sides. We have 2x plus 6 is equal to x plus 3 times itself. So this is just 2x plus 6. We FOIL this at the x squared plus 6x plus 9. And it's similar to what we just did, where you want to try to make it equal to 0 and factor to solve. So we'll just bring the 2x over, subtract the 6. X squared plus 4x plus 3 is 0. And we get x plus 3 times x plus 1. Or x is negative 3 and x is negative 1. All right. Let's see 2 or 3 more here to wrap things up. What if we had square root of x minus the square root of x plus 45 is equal to negative 5? What we want to do is we want to try to get the hardest square root by itself. So I'm going to bring this over and I'm going to bring this over. And we get the square root of x plus 5 is equal to the square root of x plus 45. Now we could square both sides because the hardest root is by itself. So square root of x plus 5 squared, and then the square root of x plus 45 squared. This will be square root of x plus 5 times the square root of x plus 5. If we multiply these, this will be the square root of x squared, or just x plus 5 root x plus 5 root x plus 25 equals x plus 45. Now remember what we want to do. We square the hardest radical. Now we get the next radical by itself, square that, and then finish it. I'm going to subtract x on both sides here, subtract the 25. You get 10 root x is equal to 20. Divide by 10. Square both sides. And you get x is simply 4. And so all that work, x equals 3. So we isolate the radical, square both sides, and then repeat. Two more to wrap up. If we had the square root of x minus 12 minus the square root of x is equal to -2. We want to get the hardest radical by itself. So let's bring that square root of x over. And we get square root of x minus 12 is equal to square root of x minus 2. And then we could square both sides. Which cancels out this radical, but over here we have to multiply square root of x minus 2 times the square root of x minus 2. Which is just x minus 12 is equal to x minus 4 root x and plus 4. Then we want to try to get this radical by itself. So first we were getting this by itself. Now we have to get this by itself and then square both sides. Subtract x. Subtract 4. Divide by -4. Just get 4 is equal to root x. Squaring both sides, x would be 60. Yeah, so I skipped a step over here. When you're multiplying this, it's the square root of x times the square root of x, or square root of x squared, minus 2 root x, minus 2 root x, plus 4. And then these combine to give you -4 root x. Square root of x squared is just x. So that's where that came. We'll do one more problem. Do this one. Square root of 6x plus 2 plus 3 is equal to 8. All right, so just like before, we'll get the square root by itself. We just get the square root of 6x plus 2 is equal to 5. And then we could square both sides. And 6x plus 2 is equal to 25. Subtracting 2. And dividing by 6 gives us 23 over 6. And that's the